To enable SNMP from the command line, use the options snmp.enable command from your storage system. You cannot set SNMP access privileges in Filer View. To set the access privileges on a host or interface basis, enter the options snmp.access command with the necessary values. To view the SNMP configuration, simply enter the SNMP command at your storage system command line with no additional options or values. To modify the configuration, use the SNMP command with the necessary parameters. To get a list of the available options, type SNMP space -- help. SNMP traps are mechanisms that alert you to significant events in your storage system. If SNMP is configured, traps are fired when a defined event, such as a network traffic interruption or line power failure, occurs. Trap information in the form of MIB object identifiers, or OIDs, is sent from your storage system's agent to an SNMP management station. For example, the NetApp Operations Manager tool uses SNMP to gather much of its information from storage systems. You can create user-defined traps in Data ONTAP if the predefined built-in traps are not sufficient enough to create alerts for conditions you wish to monitor. The traps are persistent. After you set a trap, it exists across reboots until you remove it or modify it. You use the traps.dat file to find object identifiers for objects in the MIB files of your storage system when creating traps. And you want to make sure that the condition you intend the trap can be generated in your storage system's environment. Do not set traps on tabular data. It's possible to set traps on row entries in a sequence, for example, an entry in a table. However, if the order in the table is changed by adding or removing rows, you will no longer be trapping the same numeric variables. And then to view or modify traps using the command line interface, use the SNMP traps command. This slide shows the syntax for various SNMP trap parameters. Use the SNMP traps command to display the list of user-defined traps. The SNMP traps command can be used to enable, disable, reset, or delete a trap specified by trap name. If you do not specify the trap name, all traps defined so far are acted on. You can use the SNMP traps walk prefix command to walk or traverse in order the trap list by prefix. That is, to list all traps that have names beginning with a specified prefix. To load a set of traps from a text file, use the SNMP traps load command. The trap list file name file contains a list of traps without the SNMP traps verbiage preceding each trap. To define or change a user-defined trap parameter, use the SNMP traps command followed by the trap name parameter and then the specified value. If you intend to use this feature, then you are advised to define traps in a configuration file, which is then loaded with the SNMP traps load command. If you define and load traps this way, Data ONTAP automatically backs up your SNMP configuration in snapshot copies, making it easy to transfer user-defined traps to other storage systems and simplifying recovery of SNMP configurations if there's some kind of disaster. To create a trap configuration file, you want to follow these steps. First, create a traps configuration file on your storage system. For example, /etc/mib/mytraps. The name and location of the file is at your discretion. Next, enter the traps in the configuration file in the following form: trap name parameter and value. That is, simply use the parameters of the SNMP traps command without the command name, which is SNMP traps. Third, test each line of the file by entering the SNMP traps command at the command line or by specifying the trap with Filer View, and then make corrections as needed. And fourth, load the configuration file with the SNMP traps load command. Data ONTAP now supports SNMP version 3, which provides a new security model. When authentication no privilege option is set, or auth no priv, SNMP version 3 requires an authentication login password. This feature creates a secure environment where SNMP requests must authenticate but do not have any privileges once authenticated. We use the MD5 algorithm for authentication. Data ONTAP 7.3 now provides 64-bit counters that can support high-speed interfaces. SNMP version 1 supports only 32-bit counters. At 100 megabits per second, a 32-bit counter will wrap in just over 5 minutes. This means that SNMP version 1 is essentially useless for gigabit Ethernet interfaces. All MIB2 objects supported in SNMP version 1 are also supported in SNMP version 3, as well as Data ONTAP Custom MIB. The Data ONTAP Custom MIB provides a means to obtain detailed information about many aspects of storage system operations via SNMP. For more information, please see Managing the SNMP Agent, Data ONTAP 7.3, or Technical Report 3608 called Data ONTAP SNMP Trap Management. In previous releases of Data ONTAP, aggregate size was calculated using both the parity and data disk drives. This can be viewed using the sysconfig-r command. When looking at the output of sysconfig-r, administrators look at the used column to see the amount used and the total. The total includes the parity disk. As the need for larger aggregates has increased, this calculation causes the aggregate command to reach Data ONTAP maximums sooner. Customers attempting to create 16 terabytes of data space in an aggregate would reach the maximum size before reaching 16 terabytes of data space because parity drives were included in the calculations. Using Data ONTAP 7.3, the parity drives are no longer included in the calculations when creating an aggregate. Well, here we are at the end of Module 1, and in this module, you've learned that Data ONTAP 7.3 provides auto support for quotas and backup logs. And you've learned information about the new support for SNMP version 3. And you've also learned that Data ONTAP 7.3 calculates aggregate size without including parity disks. Thank you very much for your attention, and see you in the next module.